Hi, Math to Enhance. This is page 3 of our packet. And for those of you not in class or just needing some more support, I thought I'd do a few of these problems with you. So let's start with the first row. Number 1 is a fairly straightforward radical problem. From our notes page, step 1 said to isolate the radical. So let's do that. The first thing I need to do is add 7 to the other side. And when I do that, I get the square root of x plus 6 equals positive 5. So then step 2 says that I have to raise the equation to a power to cancel out my root. Well, this is a square root, so I'm going to square both sides. And the square cancels the radical, and I get x plus 6 equals 25. And let's subtract 6 over and get x equals 19. And you can check that answer. It's going to work just fine. Let's take a look at number 2. So this is set up like a fraction, and the numerator is the cubed root of 2x minus 2, and the denominator is 6. So I'm actually dividing my radical by 6. So I'm going to cancel that. I'm going to isolate my radical by multiplying both sides by 6. When I do that, I get the cubed root of 2x minus 2 on the left, and 1 times 6, I get 6 on the right. So now I'm ready for step 2. That's the one where I raise my both sides to a power to cancel my radicals. So in this case, I'm going to cube both sides because the exponent of 3 will cancel with my cubed root. And nothing happens to my 2x minus 2. It just kind of falls out of the radical when it cancels. And then 6 cubed is 6 times 6 times another one, which would be 216. So now I have to, my step 3, I have to solve this. I'm going to add 2 over. So 2x equals what? 218. And then I'm going to divide both sides by 2, and I get x equals 109. So number 3 is an example of a problem where I have a radical on both sides. So they're separated, but there's really nothing to do with that 3. It's just got to stay where it's at, and I'm going to square both sides to cancel my radicals. So on the left side, I get the 10x. Now be careful, on the right side, this was 3 times the square root of x plus 1. So I'm going to square the 3 and get 9. And I'm going to square the square root of x plus 1 and get x plus 1. I'm going to keep the x plus 1 in parentheses. You could put 9 in parentheses too if you wanted. But the reason I do that is because it was 3 times the square root. So now it's 9 times x plus 1. The parentheses help me to remember to do my distribution property and multiply both parts of what I've just squared by 9. So I get 10x equals 9x plus 9. Subtract the 9x over, and I get my x equals 9. So let's take a look at number 6. Number 6 has a radical on just the left side. So it's isolated. I'm ready to square both sides. But this is one of the problems that when I square the right side, it's really x minus 5 times x minus 5. You don't have to write that, but you need to remember that. So you're going to do either your box method or your FOIL, and you're going to get x squared minus 10x plus 25. So now, anytime you get something quadratic, meaning it's got an x squared and an x, you need to set it equal to 0 so you can solve it. So I'm going to subtract this x over, I'm going to subtract this 1 over, because I really like to keep my x squareds positive. I don't really want my first term to be negative, but it's personal preference. And so now my numbers are going to be negative 8 and negative 3. Remember, you have your AC at the top, your B at the bottom, and I would get a negative 8 and negative 3. So let's put those in our parentheses, x minus 8 and x minus 3, because my a was 1. So when I set each term, each factor equal to 0, I get x equals 8 and x equals 3. But remember, we should always be keeping our eye out for an extraneous solution, and for sure, if we get something quadratic and we solve it, we definitely need to keep our eye out for an extraneous solution. So let's plug both back in. I'm going to plug the 8 in, and that's 8 plus 1 equals, I'm going to see if it's equal to 8 minus 5. So on the left side, I get the square root of 9, or 3. On the right side, I get 3. So the 8 works out great. Awesome. It's a keeper. So now let's try the x equals 3. So I get 3 plus 1 on the left side under the radical, and 3 minus 5 on the right side. So on the left side, I have the square root of 4, which is 2. On the right side, I have a negative 2. But 2 doesn't equal a negative 2. They're not equal. So I wouldn't have a solution for this of x equals 3, just the x equals 8. Why don't you jump over to number 4 with me? On number 4, this is interesting. This has a fifth root. So as far as step 1, as far as isolating the radical, there's nothing left to do. I don't really make my problem simpler if I divide both sides by 2. Then I actually wind up with a 2 in the denominator. That doesn't seem easier. So my step 1 is done. So step 2 says to raise both sides to a power to cancel your radical. So in this case, I'm going to raise both to the 5th power. On my calculator, or because you know 2 times itself 5 times is 32, you're going to enter 2 and raise it to the 5th power. Different calculators work different ways. If you're not sure how to use your calculator, come see me. But 2 to the 5th is 32. The 5th root of x and the exponent of 5 cancel, and I just get an x. And on the other side, the 5th root and the exponent of 5 cancel, and I just get my 64. So this simplifies very easily. I just divide both sides by 32, and I get x equals 2 for my answer. Okay, so the rest of these, try on your own and check your work and your answers in the solutions in the folder. And if you have any questions, please come see me. Thank you.